Hey everybody, I'm Mateo. Welcome back to Young Engineers of Today. Also, welcome to the final, oh yeah, no worries, it's up on YouTube at least, the final class for the winter semester. Hello, Cohen. We're going to be doing something a little bit different today. This is just going to be a one-off class, and then we're going to, go our separate ways at least for a couple of weeks, and then classes will begin back up in the spring. But yes, so that's what today's going to look like. Today's going to be a pretty relaxed class. Going to be a lot of YouTube videos to watch that are a part of this presentation, I should clarify. And then yeah, and then we can if we end up ending a little bit early, so as it goes. Let's go ahead and get this show on the road. So this is all just about sort of what's coming in the near future, potentially, and also what exists today. And agreed. Let's make it a good one. Yeah, I think I already said that. What exists today and things like that. So cutting edge technologies and possible future cutting edge technologies and things like that. Start with biomedical engineering. What do we got there? Well, biomedical engineering is a lot about prosthetics and things like that. So in this case, we've got the Cybathlon, which is the world's first bionic Olympics. Now, this means that just basically athletes with disabilities will use their respective cutting-edge assisted devices to compete in 6 major events. By bringing these individuals together from fields such as medicine, robotics, and communication, the event really looks to encourage future collaboration and innovation. So, you might be working on some part of cybernetics or prosthetics or something like that. And if you go to this event, you might meet a whole group of other people who are obviously interested in the same thing that you are, and they might have new perspectives to bring to this, and you guys might be able to work together in order to create new advances in cybernetics or prosthetics or whatever, mind-machine interfaces, anything like that. And that's one of the big purposes of this event, is to encourage people to communicate and interact with one another insofar as these events, like these disciplines, are concerned. Come on, play. There we go. I'm going to link all these YouTube videos to you guys as well, because they're going to work a lot better running on your computers than they are if you're watching them through my computer. Yeah, it is pretty cool. So yeah, Bionic Olympics. Yeah, exactly. And the stuff they do might look, like simple stuff to us, but the fact that they can do it with prosthetics, artificial limbs and things like that is amazing. And I'm glad you agree, Mateo. It is pretty awesome. The fact that they can do all this stuff. And it helps to encourage advancements in these sorts of things. They're almost like field tests for these pieces of equipment too. Like how quickly how much can humans get used to these things, and what are areas of contention? What needs to be changed? What's lacking in a bionic arm or something like that, or a prosthetic arm. In addition, you saw like the brain games, one where they're using their brain to control a game. That's like mind-machine interfaces, and that's something that's been sort of the realm of science fiction for a very long time. But we're starting to zero in on that kind of stuff as well. So, for instance, this example of a paralyzed woman being able to communicate through thought. Took them about half a year to test the system, but uh, she was able to have control over the interface with 95% accuracy and be able to communicate with her mind. Now these interfaces now have a solid foundation on which to continue to build on this technology, which they say has the potential to give humans superhero-like abilities. It really gives you the ability to interact with everything in a different way in your day-to-day life. I mean, you could have stuff like prosthetic arms or legs or exoskeletons or whatever that would be possible with the mind-machine interface. But on top of that, just being able to interface with your television or your door, or the stove or your computer in general, and be able to type and stuff like that. That would be pretty amazing. Um, it would be definitely something else. No, that's all biomedical engineering. The mind-machine interface does kind of segue nicely into AI and computer technology. Obviously, synthetic intelligence, the future of AI and us. This is basically it's an interview between President Obama and some people from Wired, and a guy from Wired, and an MIT professor, and they talk about the current state and the potential future of AI technology. Um, and it's an interesting discussion. Now, there isn't really much that's being exemplified here. There aren't really many examples in this interview, but it's kind of interesting to see the discussion and talk about um, the perspectives that they have on artificial intelligence. So I'm going to go ahead and link this one as well. Oh, gonna have ads. I'm just going to mute myself. Hey, Cohen. Oh yeah, yeah. No, I just muted my sound while the video was going on, just so you guys can watch it and not have to listen to me talk over it. So yeah, it's an interesting discussion just to sort of see how everybody feels about AI. It might run a little counter to sort of how you imagine it, but at the same time, it does provide some exciting new prospects. It brings up some important questions that need to be answered, and maybe if you find that kind of thing interesting, maybe you can be some of the people who help to answer those questions, because there were a couple there. But here's an example of something that's coming very soon. There's the Amazon Go, which is the smart store. It's an 1,800 square foot retail space in Seattle. That's coming early 2017, expected to open early 2017. Um, that has no checkout lanes. You literally just walk in, you scan your phone as you're walking in on an Amazon app. Um, you grab what you want and you walk out the store and it charges to your Amazon account. Uh, Now, who knows how this works entirely, because there are other questions to be answered there too. What if you can't pay for everything? What if you just walk in there and take some stuff and walk out and never intend to pay for it? Is it going to automatically, take it out of your card? Or, what would they do in case they can't? Do they just take it out of the next time? What if you never get enough money again? What happens? Does Amazon just eat the loss? But it's still a really neat concept. Example of, in artificial intelligence, specialized artificial intelligence. So there you go. An example of artificial intelligence, specialized artificial intelligence, like I said before, and like was discussed in the Wired video. But an example of artificial intelligence, the fact that they're able to figure out what you're buying and charge you with that it was pretty awesome. And yes, it could have the potential to be misused. All of these things can. Technology is a tool like anything else. Yeah, it could freak out and um, either think you bought more than you did, or you could buy too much and be charged. It's probably very easy to just sort of let it run out of control, because you don't see it racking up at the end. In fact, you don't see your bill until you walk out of the store, presumably. Whereas, if you're in a checkout line at the supermarket, you see the person ringing all the stuff up and you see the money go up and you go like, okay, don't actually scan this thing, because that's going to be too much or whatever. Um, but who knows? Who knows? I mean, this is a test of what could potentially be in the future, and nothing could pan from this, or you could get sort of the next example of supermarkets. Who knows? Um, Computer technology, to continue that, they're the growable computer chips being developed by IBM. Um, where scientists have devised a way of coaxing carbon nanotubes to build themselves into structures that could be used to replace silicon chips. Um, implementing this successfully could lead to faster than silicon computer chips, along with bendable electronics. Um, sort of, yeah. Yeah, it's basically it's a self building structure, and it's interesting, especially because it with the promise of carbon nanotubes or the potential of carbon nanotubes, uh, they they have promised to sidestep a lot of the problems that we run into with Moore's law, where silicon transistors are getting so small now that they can't reliably dissipate heat. So another promising technology, um, carbon nanotubes. Basically, there's a lot of promise for them. They promise to be more flexible, more durable, better conductors, better like dissipators of heat. Um, so they promise a lot of things. They could be faster. They could use less energy. Um, you could have wearable electronics, like you could have a thing that you clasp around your wrist. That's a screen, and it's a touch screen that bends. Um, Things like that. The potential of carbon nanotubes has been sort of lauded and dreamed about for the last, I don't know, 15, 20 years at least. Well, it's hard to work with because carbon nanotubes need to be very, very thin. At some point, if they're thick enough, they're no longer carbon nanotubes and they just become regular old graphene, which then means that they lose all of the properties that they have, and then you're essentially just working with pencil lead. Um, so yeah, I mean, theoretically speaking, you could go to Office Max or Target or whatever, buy a whole bunch of pencil lead for mechanical pencil, take a piece of Scotch tape and pull it off, and probably have some carbon nanotubes on there, or at least some graphene, not necessarily carbon nanotubes, but some graphene. And you could be like, yeah, I have this new way of making graphene, and that's actually what scientists used to do in the lab for a while. But the thing is, part of what provides the special properties to carbon nanotubes and graphene is the fact that they're so thin and they're single molecules of carbon, like single layers that are a single molecule of carbon. Um, so that's part of the reason why they have such special properties. Um, you eliminate that structure, and you're left with regular graphite, and then suddenly those properties are no longer there. How much does graphene run for? A lot, a lot. Um, if you're looking to sell it, though, I don't think you'd have much luck. Because despite the fact that it sells for a lot, um, you might get a few micrograms of graphene maybe by doing the Scotch tape thing. And chances are it would get Yeah, exactly. Chances are it would get ruined or something like that in the process as well, because I mean it's the glue and the Scotch tape is also adhering to it. Oops. You'll find a way. See, there you go. Exactly. You will find a way. You'll become the next manufacturer of graphene. Exactly. Now, mechanical engineering. Well, you've got the flying car, the dream of every sci-fi buff since like the 50s. There's a flying car prototype that has a maximum speed of about 190 miles an hour, and several other companies are trying to bring flying cars to the market, but they must first overcome regulation issues and safety concerns, of which there are a lot. A lot. That's other than the whole fuel consumption and feasibility technology-wise, there has been a huge hurdle to flying cars, and that's been the human element. People driving make a very dangerous driving environment. Um, People driving in 3 dimensions will make an even more dangerous driving environment. So a lot of times you have to make these things automated. Do you have the cars owned by individuals, or are they something that you can rent like a taxi? Is it going to be taxis like owned by private companies, or is it going to be paid for by the city? So is it going to be municipal? Is it going to be some combination of the two? Then you have to have regulations like the FAA step in and make sure that like everything is um, everything is flying through the skies and not crashing into each other and things like that. So the FAA would need to become larger. If it's a communal thing like a municipal or a taxi service, a commercial service, how do you ensure that these things are safe? You got to have some sort of advisory board for that kind of thing. Have I heard of the ARCA board? No, I haven't. But anyway, what is it exactly? And also, yeah, this is just what that's part of the reason why these things don't exist. It's just because there's a lot going into it. Here's a 1/5 scale model of their prototype. Oh, right, I remember the ARCA board now. Yeah, 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 the hoverboard. Yeah, it does look pretty cool. It's the one that uses the downward force, the air pressure, right? Yeah, yeah, exactly. Now there's also mechanical engineering, of course, also involves space flight because of, automation and things like that. Elon Musk wants to have an unmanned mission to Mars in 2018 in order to enable manned missions, because a lot of plans for Mars colonization involve initial unmanned missions in order to set up like the necessary infrastructure in order for humans to survive there, setting up a source of water and oxygen and power, setting up places to live and sleep and grow food and things like that. Because, if you have humans set it up when they get there, well, things could go wrong. And if things go wrong, they don't really have backup from Earth. It takes 9 months for something to get from Earth to Mars on average. It might actually be at its closest points. No worries, Hannah. It happens. We're just having a very, very easy class today. Um, uh, and yeah, it'd be fun. I think that'd be fun. Um, and that essentially means that you put these colonists in a very, very bad position. Like I haven't seen The Martian. I've wanted to, but I know enough about The Martian to know that The Martian is kind of an example of what could go wrong. It's an idealized one, sort of kind of not really, but yeah. Now, materials engineering. Diamond batteries from nuclear waste. Diamond batteries from nuclear waste. Materials engineering is the last subject we're going to cover. But diamond batteries from nuclear waste. Scientists have developed a way of converting nuclear waste into sustainable diamond batteries. Now, it's a very specific type of nuclear waste, but nonetheless, it's nuclear waste. And these batteries could be a clean and safe way to power spacecraft and satellites and medical devices. And this one actually I think is pretty fascinating. Of course, it has a whole host of, questions of its own as well, but I think it's pretty amazing regardless. So yeah, another video link incoming. Pretty exciting stuff, right? But again, it has questions of its own. Um, how much power does it put out? Can you draw more power from it? Does it decrease the half-life of it if you do? Or is it just going to put out a constant amount of power no matter what? Does the protective diamond around the radioactive diamond inside become more radioactive as the battery gets older? Yeah, exactly. These are all questions that sort of could be answered, um, or that could use answers, I should say. Um, at least as far as this technology is concerned. Now, I mean, that sounds awesome. I mean, having a battery that lasts, for thousands and thousands and thousands of years, and has a useful life of at least 5,000 years. Um, I feel like that's pretty remarkable. Now, I don't know, you know, yeah, exactly. Um, who knows? Like, and that's the thing that it goes down to 50% power because that's just the half-life of carbon-14, which means that it loses half of its radioactivity. Um, so it's still got 50% power left, and then after another 5,700 and some odd years, then you're at 25% power, and another 5,700 some odd years, you're at 12.5% power, and so on and so forth. But that's a percentage of some amount that we don't know how much it is. It could just be enough for a pacemaker, and that's it. Um, yeah, exactly. It could just be enough for like a watch, maybe. And in which case, having a watch that lasts for 5,000 years is pretty awesome. Um, more than is pretty awesome. Like the watch would break before the battery would run out. But regardless, um, there are questions that can be answered, and it remains to be seen sort of whether or not the technology pans out. Because these things, it's always unusual. Um, you never really know what ends up becoming the technology of the future. Uh, because we as humans are really bad at predicting that. We try, but like I said, we thought we were going to have flying cars and personal jetpacks and robot servants in like 1970 if you ask somebody from the 50s. Um, oh, longer than that, because again, it's the half-life, so you only lose half of the remaining power. So it's not like it goes from 50% to zero. It goes from 50% to 25%, and then from 25% to 12.5%, and then from 12.5% to 6.25%, and then from 6.25% to 3.125%, and so on and so forth. And each of those takes 5,700 and some number of years. 740, I think, what it was, or whatever. Anyway, um, excuse me. But yeah, so it's a remarkable thing. But who knows, if we run into setbacks that mean that it doesn't pan out. Who knows what sort of random discoveries that scientists are going to stumble upon in the next 20 to 30 years that can easily be adapted into current technologies that turn it into, the next big thing. I mean, we didn't get flying cars and personal jetpacks and stuff like that by the year 2000 like people thought. But they never would have guessed that the internet and smartphones and things like that would have become such a large part of our society. They wouldn't. A lot of science fiction doesn't even touch on anything like that. Doesn't anticipate it, and yet here we are, and we've got this. I've got this means of reliably communicating to you over miles and miles and miles. If you guys were on the other side of the world, it wouldn't matter. Um, we could still do this. Um, and it's brought our world together in ways, more ways than we can even really anticipate and understand. This interconnectivity that we have now, and this constantly sort of being able to tap into that connectivity and be networked with people and technology and things like that. Um, so that's something they never would have anticipated, and yet here we are now doing that. Um, so it's kind of amazing to think about how the future goes in an entirely different direction than what you might anticipate it might. You know, we've been waiting for the singularity for the last 30 years. We've been waiting for fusion for the last 30 years, cold fusion, or just regular fusion even. There's flying cars for the last 60 to 70 years. The list goes on. AI for oof, a while now, since at least the time of Asimov. Um, and those haven't panned out. But again, we've got, you know, absurdly powerful computers, and we've got solar power, and we've got, you know, ion engines and things like that that they never would have anticipated. Who knew that rockets could run on things other than chemicals and nuclear fission? Anyway, next semester, if you guys are going to be joining us for next semester, um, we got a few things planned out for you guys, or lined up. Actually, a number of them. There's going to be CNC milling, so on the mill and shop bot, you guys are going to be messing around with that in lab, and probably on the class side of things, there's going to be like 3D modeling, like Fusion 360, and then there's going to be a mesh mixer and stuff like that, and all that kind of stuff. So we're going to go over that. Cybersecurity should be pretty interesting. This is actually going to be an entirely new topic for us, so I don't know exactly what we're going to be covering. Um, but I guess we'll see exactly what happens. Aerospace, so rocketry and planes and things like that, so how all of that works out, that's pretty awesome. Programming and racing quadcopters, finally. So just as it says on the tin, being able to program and race quadcopters. That should be pretty awesome. But that's just sort of a taste of what next semester is going to look like. We're going to cover all these things. We're probably going to cover like one or two other subjects in addition to that. If I was a betting man, I could be wrong though, but that's kind of what I think. Regardless, that's what next semester is going to look like. I need to remind you guys that tomorrow you're going to have a lab, or tomorrow there is a lab. So, you know, don't forget about that. But other than that, that does it for today and for this semester. So if we're going to see you in the spring, have a wonderful couple of weeks. We'll see you in the beginning of January. If not, well, I really hope that you pulled something from this that set that spark in you and got you interested in this. Something that you could look at and go, yes, I could do this. I could be a part of this. Septicopter, yeah, exactly. I could be a part of this and help to answer these important questions that, you know, determine the future of technology and human development, things like that. Because, you know, it's a very noble aspiration to be a creator, and you know, especially if it's for the betterment of human civilization. But yeah, so see you later, Mateo. Have a Merry Christmas. Hopefully we'll see you in a few weeks. But yeah, if you thank you. If you don't end up coming back, I hope you pulled some interesting stuff from this, learned a little bit more about yourself and about engineering in general, and I hope it gave you some direction in what you want to go into, you know, in life and things like that. Certainly, Hannah, no problem. You have a good night too, and thank you. See you next semester. All right, sounds good, Mateo. But yeah, you guys are more than welcome. If you have any questions, you can ask them. Otherwise, you can head out. All right, see you later, Hannah. Have a wonderful at least few weeks. Otherwise, good luck. Best of luck with the rest of your life. Thank you. You too.